46 permutations. Array nouns. All possible permutations and return the answer. Okay, 没关系. Okay, and this question we can use. I think for this question we can use backtracking to do. And let's start this. Maybe let's check if it is not num, just return empty. Also, the basic algorithm for this is we add one number and to the output, and then choose from the rest of the numbers, and then we added them one by one. And then once we reach once we have no numbers left in the list, then we can return append this current result to our global result. So we first set a global result here, and since we're using the backtracking, I think I use a recursion to do it here. And, let's say it's BFS, and every time we will change, we will select one number from the nums, so the num will decrease by 1. Here. And yep. So if the length rest, and the base case is if the number left in the number list is equal to 0, so then we can append the current pass. Yeah, we need another variable to check the current pass. So we'll append the current pass to our result. And and then return. So on this level, we just need to select one number from the number list. So we iterate each number here and choose it as the first number at this level. So we go to next level with the rest of the numbers. And then we add this to the pass, this number to the pass. Be careful, this should be a list. And yeah, I think this is it. And we can just return result. Let's check if this is correct here. Yeah, we need to call this function first. And at first, the pass is just empty. We don't need to worry about the remove or add because we just pass the new pass into the next recursion. So we don't need to worry about remove it. Let's run it first. Okay. Okay, it goes. And the time complexity for this is just the number of all the permutations here. Should be the n 的阶乘, how to say, n 的阶乘. And the permutation, yeah, n 阶乘除以 n 减 k 的阶乘. Yeah. Okay, cool. Next question is 332 coin change. You're given coins of different values. So coin is actually it doesn't say if the number are integers or not. Yeah. We have infinite number of each kind of the coin. Since we have this condition here, we can actually construct the DP by just one coin at a time because the coins don't like affect each other. Only when we add a new coin, we will affect the previous result. But the sequence of the order of the adding the coin doesn't matter here. And we first define, I think I will use a dynamic programming to do this problem. So DPI here, I'll define it as the minimum number of coins we need to use to get I amount of money. So the relation here would be the DPI should be the, because we have minimum number of let's say we choose this number coin I, we use this coin, we use this coin this time, so we need to go back to this amount of money and then plus 1, and we just compare to previous result. Actually it's when we don't have this coin, we have DPI. When we don't have, because we update this every time we have new coin. Okay, so the size of DP should be amount plus 1, because we want to add DP0 to 0. So DP amount is the result. So size is amount plus 1. So let's see. Let's first, if amount, check amount. If it's smaller than 0, we can say return -1 here. Okay. If not coins, we also return -1. Then we construct the DP function here. Since we want to have the minimum number, so we first initialize it as the infinite number. Range amount plus 1, and we assign the initial number to 0. Now we can iterate a coin in coins. Each coin we iterate each possible amount here for amount, and 1 to amount plus 1. So we update DP amount equals to minimum of DP amount minus coin plus 1 DP amount. Yep. And then when return would be DP amount. If DP amount is smaller than the infinite number, yeah, if we can change it, else -1. Should be correct here. Wait. List autos range. Oh yes. So here I think we should, because amount minus coin might be smaller, so we need to start with coin here. Let's take this example here. got it. Yeah, because we need to start with coin, or we will get negative number here. Okay, it passes. Third question. So I met this question in the ByteDance interview, but I am unable to do this at that time. So the question is asking the binary tree non-consecutive sequence. So needless to say, we need to use recursion to do this, and can use, of course, we can use post order, so we can get the result at this root level. We just the result depend on what the result is of my left child and right child here. So based on what data we can decide the longest one at this level is we count how many like increasing number from the left and right, also the decreasing like current decreasing numbers from the right and the left. So if we have these two numbers and we can calculate what number should be pass on this level and what the max global max we can update here. So we can have the global max. Let's say global max here is just 0. If we use a list, and it can be passed, it can be changed. But if it's a number, it can only be changed. We need to other way to 声明这个. So here, let's make example first. We have one. Let's use this. One, two, two. One. So actually at this level we have the increasing is 1, is 2, including this number, including this. Decreasing is 1, including this. And at this level, at this one it's just 1 and 1. So at this level, because we are smaller than that, so this becomes 1 again. This should be 2 because it's smaller than this, it's decreasing. And when this comes here, actually this doesn't affect because this number is not consecutive. So at this level we have here is 1, here is 2, and we output is 1 plus 2 minus 1 equals 2. So it's 1, 2. That's the correct result here. So we need to have the, so we need to get the, say, right incur and the left decrease, right decrease from the left side long. Okay, so first is recursion function, defining function to do this. Recurse root. If root is first base case is root is now just return 0 and 0. Otherwise we go to the left and the right. Recurse notes the right. Left. we first initialize this level number. Current increase equals 1, and the current decrease is 1. Then we update if root right is not none. We can update it, and so and root right value. The root right value equals to root value plus 1. It means this is a decrease. So current decrease equals to maximum number of current equals to right decrease plus 1. Else if this is increase, we have increase equals to left right increase plus 1. Same for the left part. We do the same thing for the left part, but here we need to have a maximum number. Compare with previous one. Okay, now we can return. First, we need to update the global max here. Global max 0 equals to max of global max 0, and the current decrease plus current increase minus 1. Okay, and what I should return is current increase and current decrease. So the next level can calculate this number. Let's just recurse root and return global max 0. Works. Okay. Global max. Okay.